The remainder of what we look at now in Chapter 16 is going to lay a foundation that we can use, that we will use to discuss interference, which is coming up in Chapter 17. So far what we've done is provide a mathematical description of waves in one dimension. So those are waves that move along one line or on a string. It's not the only kind of wave. We also have two-dimensional waves and three-dimensional waves. So our PhET simulation here is showing a water wave, and that's going to be the next thing we talk about. So in the simulation that we just looked at, or something that I'm sure you're familiar with, if we throw a rock in the water, we'll see water ripple outwards in circles. This kind of a wave, these circular ripples that are spreading out, they're called circular waves. So circular waves, and those are two-dimensional waves. So when we have two-dimensional waves emanating out from a source, they're called circular waves. Just like one-dimensional waves, the highest point is called a crest. So this is a crest and this is a crest. A little bit hard to draw. In between crests are troughs, of course, the lowest points. For two-dimensional waves, these circular waves, we can trace the crest all the way along. So we can draw a line that represents these crests. I'm doing this on my trackpad, so it's not so good. I won't draw the whole way around because my finger is just getting a bit too shaky. So these lines, and they're represented in a better picture over here by these lines represent the crests. And so all of these lines, these circles here, are the high points or the crests. The crests, when we're in two-dimensional waves, we normally call those crests wave fronts. Okay, so now we have another name for the crests. They're called wave fronts. What can we say about the wave fronts? They're going to be a distance of one wavelength apart. So distance between any two crests is a wavelength, just like any two troughs. And one place that we're going to look at, that we're going to study, is what if we get far away from the source and we look at a small bit of those wave fronts? So what if we only look at about that much? Well, if we're far away and we're only looking at a tiny bit, then these lines right here, they're approximately straight and they're approximately parallel. So if we're very far away from the source, then our wave fronts appear to be straight lines. So that's something we're going to approximate and use to study our two-dimensional waves. Next, we'll move on to three-dimensional waves. As a reminder, in one-dimensional waves, that might be something like a wave on a string. Two-dimensional waves could be like water ripples on a pond. They're called circular waves. And in three dimensions, we have light and sound, and those are called spherical waves. So three-dimensional waves are called spherical waves. So you can test that a light wave is three-dimensional. All you have to do is turn on your overhead light. So you can see that light no matter where you are, and that's because the light wave traveled out in all directions. So there's the source of your light. It travels out horizontally, it travels out vertically, and it travels out in front of you as well. So the light travels out in all these directions at once. If you're trying to imagine it, you might think about blowing up a balloon that expands outwards in all directions in the same way. So then our light waves, they're not just circles, they're spheres. So they expand out in every direction at the same time. So we still have crests of those waves. Those crests are still called wave fronts. So we still have wave fronts on our crests. Let's see if I can label those as crests. So a different color. Crest. And let's think about those crests a little bit. The crests, rather than being circles like they were in two dimensions, now they're spheres. So they create shells, spherical shells around the source. If we get far away from our source, so if we just pick a little bit of those crests, if we get far away, and that's what's trying to be represented right here, then those crests, those spherical shells, are like parallel planes. So they're not one-dimensional like they were with the circular waves. Now they're two-dimensional. They're like planes. And in this case, we call these guys plane waves. And this is something we're going to use as a resource in Chapter 17. These are plane waves. Okay, so that's the nature of 1, 2, and 3-dimensional waves.